Hello, Ovesen.net again. I hope you are all fantastic. This might be a short video, I don't know. I'm going to build something. What I have here is a pile of electronic components, and it is a kit for building a cartridge for the Commodore 64, the Final Cartridge III+. I bought this one on eBay from a seller called Kirsti73, a Norwegian seller in fact. And I know there are several other sellers out there, but it's a while ago and I thought I'll assemble it now. The Final Cartridge III is a cartridge for the expansion port of the Commodore 64 or the C128. It was developed in 1987 by a Dutch company, and it provides over 60 additional functions to the Commodore 64. For example, there's extensions to the basic commands, there's a fast loader and saver, and freezer and machine code monitor. It also contains a graphical user interface similar to GEM or Windows, if you like. Okay, before I start to heat up my soldering iron, I'm just gonna order these components and have them in a neat fashion laid out. The kit didn't come with any assembly instructions, and the ad on eBay stated that the seller has assembly instructions on her blog, but I couldn't find anything there either, so I think I'm on my own, or I have to Google to find some instructions, but I think I'll be okay. The main part of this cartridge is this EEPROM chip here, which contains all the extra code for the Commodore 64. These are just logic chips, I guess. There are two switches here, or push down buttons, LED, small capacitor, two electrolyte capacitors, some resistors, and these are diodes, I guess. The nice thing with this design is that it's only through-hole component, so it's easy for amateurs to solder. So first thing you need to figure out is which side is up. Which side should a component be on to, and it's the side with the print. The layout of the components are printed onto the front side. The next issue is which way do the component go onto the PCB, as there are of course two different directions. And the thing is to look for this little notch here on the board, and there, and then on the component you find the notch 2. This is for the integrated circuits, at least for the components like the capacitors. You need to know which is plus and which is minus, which should also be printed onto the board. I just start by placing the different ICs onto the PCB. It might be a good idea to put sockets onto, but I think I'll skip that now. I'm not really sure if it will be too high for fitting inside a cartridge. So I place the ICs in their position where they should be placed onto the PCB, except this one should be that direction. The PCB only labels the chips as IC1, IC3, IC2. to find which of the actual ICs goes where, I had to look at the web page of the seller, which stated that, for example, IC3 is the L74LS133 chip, which is there. So I now think everything is correct. So let me place the IC onto the PCB. It doesn't fit quite well. You have to bend the legs a little bit, I guess. So I just push all the legs carefully in one direction. Okay, there's the first one. Okay, they're in place. I have double checked that the direction is correct. I can turn it around now and do the soldering. So this is gonna be quite some soldering job, but I'm up for it, and start by applying some flux to the soldering points here. Okay, let me go ahead and do the first one. Okay. And then I do the diagonal pin next. Okay, that was the EEPROM chip. Looks okay. I'm gonna inspect it closely with the magnifying glass. I looked through the magnifying glass and they looked mostly okay. I did reflow all the solder joints here just to be sure. So now I'm gonna go with the rest of the chips. Alright, that was the ICs. They all look good. So next is the rest of the components. I take the switches now because they only fit one direction and easy to assemble. Soldering a component that has plastics inside, you better be quick or else you might melt the plastic inside. These look fine. Next up is the resistors, which there are 5 of, and on the PCB these are marked as R1 through 5. And the direction of a resistor doesn't matter, so you can put it either way. However, you must find the correct resistor value, and to do that you either have to read the color codes on the resistors, or you simply just measure them with a multimeter, which I've done. So these three are 3, 4 and 5 is the 4.7 kilo ohm resistors. Just put them in and bend the legs on the back side so they keep themselves in place. And that was 3 and 5, no, 4 and 5, no, this is R3. R1 is 1.2 kilo ohms. It's this one here. Last resistor is the R2 and it is it's an 18K resistor. So then I just solder them on from the back side. Okay, that was the resistors. Now I just cut off the legs. Now the rest of the components, it's very important that you get the direction correct, because diodes and capacitors work in one direction only. So I'll start by soldering on the LED. The LED is the D6, which is here on the PCB. And here I have a problem because it's not obvious what is plus or minus. So for the LED it has one leg longer than the other, and that means that the shorter leg is the minus, or the negative side. So to figure out which is the negative side on this connection point here. So looking at the back side of the PCB, I see that this side of the D6 LED comes through to this rail here, which goes around all the PCB, and on the other side this left point comes from this logic chip here, so probably the left pin is the plus and the right pin is the minus, so I'll go with that. So then I put the long leg on the right side, the left side, and the shorter leg on the right side. Yeah, that's right. Same thing with the capacitors. They are directional aware, and you have to find the plus and the minus is labeled onto the capacitor, and it's also the shorter leg, so that's easy. And also here there are no marking on the PCB in which is plus or minus, so just had to figure it out by looking at the backside of the board, and I see this point here goes to the negative rail, which goes around the whole board. So then I know that it's the left pin that are the negative side. So C2 is a 1 microfarad capacitor, and C3 is a 10 microfarad capacitor, and they are in opposite direction. So this one has a negative on the right side and this has a negative on the left side. C1, which is down here, is a 1 nanofarad capacitor, and these small ceramic capacitors, they are not polarized, so it doesn't matter which direction you put them in. Okay, soldering. Finally, the last pieces is the diodes, and these are also polarized, so you need to find the correct direction. And all these 5 has the same value, so that's easy. They go here and here. So the direction of a diode is that the black ring on one side is the cathode, and which is the negative side, and this one is also marked here with a white band, so the black side should go with the white band. Okay, soldering and the last components. All the components have been soldered, and hopefully nothing's wrong, so I just clean up the backside with some alcohol to remove the flux residues and everything. So the soldering looks okay. Maybe not the prettiest soldering job in the world, but for an amateur I think it's excellent. Other side looks okay too. Maybe this one wasn't that good, but it should be working. All right. Time to test, and I have hooked up one of my Commodore 64s. So I turn off the machine and insert the cartridge. Final Cartridge III+. Moment of truth. All right. Cartridge is working. LED is on. And on the screen you see the desktop V2 menu system. So it went straight into the desktop instead of booting BASIC. Okay, you can move the pointer by using the F keys, and then press hold the Commodore. Okay. I think I have to try and connect the joystick. So here Here's many types of tools. You have a time and alarm, and you have utilities with the calculator and disk and tape utilities, notepad, system. Let's try basic. Okay, so now the machine went into basic, which is let's call it basic plus. So I haven't really read all the documentation, but if you press, for example, F1, it's shortcut for list, and Shift F1 goes into the machine code monitor. Let me try the freeze switch. Nothing happens now. Let me try the reset switch. Okay, so the reset switch goes into the regular Commodore Basic. Seems like. No, it's the same. It has additional commands, yeah. So the point with the freeze is that when you are running a software game or something on the Commodore, you can press the freeze button and it will instantly freeze the execution of the running program. Then the cartridge takes over and you can examine the memory of the computer, and you can insert cheat codes or steal graphics, and even modify the program and then save it to disk. So really handy if you are into these kind of things. So the next thing I wanted to do was to find a case for the cartridge, but and I got one here, but it doesn't fit very well, so I think I'll need to get something printed out with a 3D printer or something. But for now I have to use it without the case. Okay, that's it for now. I made myself a handy tool, the Final Cartridge III Plus. Yeah, it was a fun project. Hopefully I can use this cartridge in the future in other projects. Alright, thanks for watching. Hope you learned something and enjoyed this video. Please subscribe to my channel below if you want to see more retro computer and techno stuff. Thanks again, bye bye.